Everybody, we got an interesting question. We are expected to integrate integral 0 to infinity of 1 negative e raised to the power of negative 1 over x squared times dx. So foremost, what I wish to do is I would like to utilize integration by parts. In that context, I would take u to be as 1 negative e raised to the power of negative 1 over x squared. So if we were to differentiate this, differential of 1 will give me 0, followed by differentiation of e raised to the power of negative 1 over x squared times differentiation of e raised to the power of negative 1 over x squared. So this is equal to negative e raised to the power of negative 1 over x squared. Now this quantity is, let me show that here. Now can I write this as d of x to the power of negative 2? Can I do that? Now this negative sign is present here, so I want to move that negative sign outside. So negative times negative will give me positive. So now I need to differentiate x raised to the power of negative 2, which is going to give me negative 2 times x raised to the power of negative 2 negative 1, which is equal to negative 2 times x raised to the power of negative 3. Okay. So that is what we are going to be writing. So it's going to be negative 2 times x raised to the power of negative 3 times the differential operator dx. Now this can be further rewritten as negative 2 times, I'm going to, okay, let me write that down, x to the power of negative 3 times e raised to the power of negative 1 over x squared times dx. Let me further synthesize this and rewrite it as negative 2 over x to the power of 3 times e raised to the power of negative 1 over x squared times dx. This is my du. Okay, fair enough, we got our du. So let me probably place a nice box. Of course the box is too small. Okay, I hope you're able to catch it. Now having got that, now it's time for me to go to dv. Now dv is equal to, what have we got? I have got just dx, so place that dx. I need to get v, I integrate both sides, I get v is equal to x. So now use integration by parts. What is the formula? uv negative integral v du. This is a formula. Take the value of u, which is 1 negative e raised to the power of negative 1 over x squared times the value of v is x. This has to be within the limits 0 to infinity, followed by negative integral v du. My v is x, my du is negative 2 over x to the power of 3 times e raised to the power of negative 1 over x squared times dx. I got a negative and a negative, so that's going to be positive. So we got x times 1 negative e raised to the power of negative 1 over x squared within the limits 0 to infinity. Negative, negative, positive, and x can be cancelled. So that in turn is going to give me 2 times integral e raised to the power of negative 1 over x squared divided by x squared times dx. So that is looking good. Now let me just integrate this quantity first. Okay, so for that what we are going to do is I will just consider this integral quantity first. So consider integral e raised to the power of negative 1 over x squared divided by x squared times dx. Now I'm going to be making the following substitution. Let p be equal to 1 over x. This is nothing but x raised to the power of negative 1. I differentiate, I get negative 1 times x raised to the power of negative 1 time followed by a negative 1 times dx. This is negative 1 times x raised to the power of negative 2 times dx. This is negative 1 over x squared times dx. This is my dp. Now I don't have a negative sign here, so therefore I can rewrite this as dx over x squared is equal to negative dp. So having got that, this is rewritten as e raised to the power of negative of 1 over x raised to the power of 2 times dx over x squared. Of course, we got the limit 0 to infinity, 0 to infinity. Now 1 over x is taken to be as p, so substitute that value. So this is equal to integral 0 to infinity e raised to the power of negative p raised to the power of 2 divided by dx over x squared is dp. So place the dp there. It has got a negative sign, so place the negative sign there. Now we will have to change the limits. Actually, we cannot have these limits, right? We need to get rid of the limits that we have placed here, but we got to have a new limit. So what is the new limit? I made the substitution. Let me go back to the substitution. So the substitution that we add here is p is equal to 1 over x. And x takes the values 0 and infinity. So as x is heading towards 0, what happens? P will head towards infinity. And as x is heading towards infinity, p will head to 0. So I've got, in place of 0, I've got an infinity. In place of infinity, there is 0 there. Now this can be flipped. The sign can be flipped. So you got 0 to infinity and you get e raised to the power of negative p squared times dp. Now I have already done a video of showing how to integrate a quantity like this. I will place the link for this video in the description, so please kindly see that. So the value for this is going to be root of pi divided by 2. Now having got this, what I'm going to do is I'm going to substitute it in this place over here. So this is the point of my substitution, because I have considered this quantity and I've then worked it out. So let me take this as equation A. So therefore the equation is rewritten in the following fashion. So let me just copy this off and come down and make the paste here. So this is what we had, and we have successfully evaluated this quantity, right? We don't need all these extra fittings. So this is substituted here. So that would mean I got x of 1 negative e raised to the power of negative 1 over x squared with limit 0 to infinity, positive 2 times root of pi over 2 is substituted. So 2 and 2 can be cancelled, giving me x of 1 negative e raised to the power of negative 1 over x squared. Limits are 0 to infinity and you got a root of pi there. Now the main thing is we need to evaluate this. So I substitute the upper limit. So now I need to consider this. So let me just consider x times 1 negative e raised to the power of 1 over x squared, and I need to consider the upper limit and the lower limit. So as x is heading towards infinity, I need to get the value for this. So what I would do is I would write it like this: 1 negative e raised to the power of negative 1 over x squared divided by 1 over x. So now you will understand why I'm doing this. Now as x tends to infinity, 1 over x will tend to 0. So this is going to be 0, and 1 over x tends to 0. So e raised to the power of 0, that's going to be 1. So you get 1 negative 1, which is 0 by 0 form. So that would mean we need to apply L'Hopital rule. So applying L'Hopital rule. So we have to evaluate limit x tending to infinity of x. In fact, let me write this down: x times 1 negative e raised to the power of negative 1 over x squared. Now I have rewritten this as limit x tending to infinity of 1 negative e raised to the power of negative 1 over x squared divided by 1 over x. Now L'Hopital rule is nothing but differentiation of the numerator divided by differentiation of the denominator. So that would mean I will have to obtain the differentiation of the numerator In this case, differentiation of 1 is 0. Now differentiation of e raised to the power of negative 1 over x squared, that's retained as it is. I need to differentiate this quantity, negative 1 over x squared, right, divided by differentiation of this quantity 1 over x, that's x to the power of negative 1. So let me just get the differentials. So this is equal to, you don't have to place 0, but I need to place e raised to the power of negative 1 over x squared. And this is actually, since I have a negative sign, this would become positive. Now 1 over x squared, I'm going to write it as x to the power of negative 2. So if I were to differentiate this, I get negative 2 times x raised to the power of negative 2, negative 1. And that can be rewritten as negative 2 over x raised to the power of 3. So this is going to be negative 2 over x raised to the power of 3 divided by d of x raised to the power of negative 1. Differentiating this is going to give me negative 1 times x raised to the power of negative 1 followed by negative 1, which is negative 1 over x squared. So this is going to be negative 1 over x squared. However, the negative signs that you see here get cancelled, giving us 2 times e raised to the power of negative 1 over x squared divided by x raised to the power of 3. Now you can actually flip it and place x squared over here. So that would mean you have 2 times e raised to the power of negative 1 over x squared divided by x. Now applying limits, as x tends to infinity, 1 over x will tend to 0. Now this will tend to 0, so that's e raised to the power of 0, that's going to be 1. And 1 over x, x tends to infinity, 1 over x is going to be tending towards 0. So you have a 0 there, outcome being equal to 0. So that's for the first part. Now having got the first part, we need to go and get the second part. Now we can easily obtain the second part. Now the second part, I'm going to go back to this consider. Okay, so if you were to consider this quantity, right, x is tending towards 0. When x tends to 0, this quantity is going to be tending, let me just, it's better I copy it and I'll move it so that we can discuss better. So let me paste it here. Okay, so this is what we have to talk about. Now we are looking for x tending towards 0. Now when x is tending to 0, 1 over x is going to be tending towards infinity. Okay, so this is going to be e raised to the power of negative infinity, right? So that would mean this term is actually going to be tending towards, no, because this is going to be equal to 0. So if this is equal to 0, you have 1 there, and then x is tending towards 0. So obviously this is going to be 0 times 1, which is going to give me 0. Okay, so ultimately the solution for this is gone, right? This segment is gone, and all that remains is root of pi. So that is the solution to this question. So let me write that down. So that completes this beautiful solution. Please like, share and subscribe to our channel, and until we meet again, have a nice day. Thank you.